So these are new slides for chapter 6.4. This is the normal approximation to the binomial distribution. So what this is, if you think back to the binomial distribution, those were problems where you had either one of two outcomes, like a true and false, a success and failure, the binomial ones. And the problem with that is that when n gets really, really big, okay, n meaning the number of trials that we do, and what they go by is 100 trials or more, the calculations become pretty difficult. Because those calculations become very difficult, they found out that the normal distribution actually works as a really good guide to estimating for the binomial. Okay, so when you have something that, like I said, is you have two options: a success and a failure. Okay, and you're doing a lot of different trials with them. You're able to use the normal distribution or a bell curve as an approximation for these binomials. Okay, so that's what this section is about, is using our normal distribution for binomial type problems. Okay, now there are only times when you can use it. You can't use it when it's too small either. So the rule of thumb is this: when you take n times p and n times q, they both have to be greater than or equal to 5. N meaning how many trials you have, P is, remember, the probability of a success, and Q is the probability of a failure. Okay, so these two things have to happen in order for the normal distribution to work. If they don't, if it's too small, the normal distribution doesn't do a good job of approximating. Okay? In addition, then, some things to think about for binomial. Binomial, since there are only two outcomes, you're right or wrong, it's discrete, meaning the amount, like, okay, how many successes? Let's say you have 20 trials. How many successes could you have? Well, you could be saying, what's the probability of having 8 successes? The problem with that is you can have 0 successes, 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 20. But what about in between 1 and 2, 2 and 3, 3 and 4? There are gaps there, right? Because it's discrete. They're counting numbers. They're not decimals. But the normal distribution is continuous. There's no gaps in your bell-shaped curve. And so because of that, we have to do something called a correction for continuity. Okay? What that correction for continuity does is you add and subtract a half onto each number. So if you're looking for the number 8, you're actually looking for anywhere from 7.5 to 8.5. Okay? We're going to show you how to use that. It changes when say, if we're ever looking for greater than 8, or greater than or equal to 8, or less than 7, or something like that. But we'll show you some of those. So here's what you should have down. Here's a chart you should have down in your notes. What this is this tells you how much to add or subtract. Okay? This tells you how much to add or subtract. When you're looking for an exact value, okay? So for instance, I'm going to use the example of 8. You are actually looking for the numbers between 7.5 and 8.5. That's what this is telling you to do. Okay? If you are, say, looking for, and we're going to use 8 for all of these. If you are looking for greater than or equal to 8, what you do is you take 8 minus 0.5. Because think about that. You want to include 8, right? greater than or equal to 8. So because of that, you have to go a little bit below 8. That's that little correction for continuity. If you're going just greater than 8, you don't want to include 8. So you're using the correction of 8.5. Okay, this would not include 8 at all. So remember, you always have to have that little correction. And if you're including 8, you go a little bit less than 8. If you're not including 8, you go a little bit more than 8. And it's completely reversed if you're going less than. So if you're going less than or equal to 8, you want to make sure to include 8. So you add 8, or I'm sorry, you add 0.5. Because now if you're going less than 8, you want to give it a little bit higher so that when you go less than 8, you include 8. If you don't want to include 8, so it's not equal to, just less than 8, you would start at 7.5. Okay, so it's important to know these. You'll have this chart for the test, so you can use that. But it's once you get used to it too, it's a lot of common sense. Okay, in all cases, the same rule for binomial applies. So your mean is n times p. Your standard deviation is the square root of n. The square root of n times p times q. So keep that in mind. Okay. Here's a little step-by-step procedure that you can write down if you feel like you need it. It's a practice thing. I think when you do enough practice, you don't really need this. I guess I would almost suggest if you don't want to put it in your notes, make note of it in the book. I don't know what page it is off the top of my head, but it is in the book, and you can use it on your assignment. So first thing is check to see whether the normal approximation can be used. Okay. If it can't be used, you would have to just go about it with the regular binomial formula, the way that we used to do it the old way. And that's n times p and n times q. They have to be greater than or equal to 5. Then you find the mean and the standard deviation, which was the formula at the bottom of the last slide. 3 and 4, I think, are kind of together. Write the problem in probability notation, and then you rewrite it using your continuity correction factor. Okay, so I'll show you that step. I think step 3 is really good while you're getting used to this whole thing. But once you get used to it, step 3 and 4 can kind of be combined into one. And then you find the corresponding z-value, and then find the solution. So all this stuff, this is stuff that we've done before. All right, even technically this stuff is. So here we go. A magazine reported that 6% of American drivers read the newspaper while driving. If you have 300 drivers that are selected at random, what's the probability that exactly 25 will say they read the newspaper while driving? So first thing is, this is binomial, because you got two options. Either they read it or they don't. N is really large, 300 drivers, that's over 100. And so now we want to see, can we actually even use this binomial or the normal approximation for it. So here we go. The probability of a success would be reading while driving, so that's 6%. A failure would be 94%. You just go 1 minus 6%, and then N is 300. So we check to see whether we can use it or not. So 300 times 0.06 and 300 times 0.94. Both numbers, 18 and 282, both of those are greater than or equal to 5, so we're good to go. Okay. Next step, find the mean and the standard deviation. So our mean is just n times p, so 300 times 0.06, so that's 18. Our standard deviation is 300 times 0.06 times 0.95, and the square root of all of that, which is 4.11. Okay, so now we need those. So now treat this like the first two sections in this chapter that we did, chapter 1 and section 1 and section 2, where if they told you this is your mean, 18, and your standard deviation is 4.11, what's the probability of finding exactly 25 people? You kind of think of it that way. So rewrite it thinking that x is 25. Okay. So there it is. We're looking for the probability of x equaling 25. Sorry, this kind of got overlapped here, but this says P of x equals 25. So back to that chart that I said that we use for the correction, the continuity correction. If we're looking for exactly 25, we're going 0.5 less and 0.5 more. So again, we're just taking 25 and subtracting 0.5 and adding 0.5. So now we actually have two numbers that we have to find a z-value for. And you do this the exact same way that we did it in section 2. And use your z formula. So you plug in 24.5 minus your mean, which we just found, divided by your standard deviation. You do that for both. And you get these two values, 1.58 and 1.82. And now what you're going to do is go in the back of the book, page 782, find the values that correspond to these. Those values for 1.58 are 0.9429 and 1.82 are 0.9656. Subtract the two, and the area between it is 0.0227. So that right there is the probability that you would find exactly 25 people out of 300 that read the newspaper while driving. What if we're looking for, like, this is a greater than or less than problem, okay? So of the members of a bowling league, 10% are widowed. We got 200 bowling league members, so again, N is very big. Find the probability that 10 or more. So that's basically 10 or more would be greater than or equal to 10, okay? First thing we have to see, can we actually use the normal distribution? 200 times 0.1 and 200 times 0.9 give us 20 and 180. Both of those numbers are greater than or equal to 5. Find the mean and standard deviation. Mean is 200 times 0.06, 20. Sorry, that overlapped. Standard deviation is 200 times 0.1 times 0.9. Take the square root of all of that, and you get 4.24. So you got a mean of 20, standard deviation of 4.26. Okay, so now write it as like, what are we looking for? Sorry about this. We are looking for the probability of x being greater than or equal to 10. Greater than or equal to 10. We want to include 10, remember? So we're going to go a little bit less than 10. This is one of the ones from our chart. We're going to subtract. So using that continuity correction, we're actually looking for basically greater than 9.5. Think of it that way. So if you were doing this and they just said, what's the probability of being greater than 9.5, you would turn 9.5 into a z-value. 9.5 minus 20 divided by 4.24. Your z-value is negative 2.48. Go back of the book on the table. That number corresponds to 0.0066, so that came from right there. But we're looking for greater than. Remember, this number is always less than. So we just subtract it from 1. That gives us 0.9934. So about 99.34% a percent chance that 10 or more widowed people are in a random sample of 200 people from a bowling alley. Okay. All right. So that's the gist of this. The only thing that's really going to change from example to example is this continuity correction. Okay? Are you going less than? Are you going greater than? This stuff is all things that we've been doing the last few sections. Same with the z-score. Okay, so don't let that fool you. Write down any questions you have.